So we've learned about the derivative of the natural, exponential, and logarithmic function. There are actually derivatives when the base is not e, but we don't see that in this class. So just for the natural, exponential, and logarithmic function, let's do two application problem. So an investment of $5,000 earns interest at an annual rate of 6% compounded continuously. All right, so that should raise a very big flag there, the compounded continuously. Find the instantaneous rate of change, and they didn't really have to say instantaneous. Find the rate of change of the amount in the account after 3 years. Okay, we're compounding continuously an investment. You need to go directly to PERT. All right, so A is equal to P-E-R-T. Anytime you read compounding continuously, you're going to use this formula. Now, let's see what numbers we have and what we don't have. So an investment of 5,000, that's going to be P. So P is equal to 5,000. Annual rate of 6%, that's R, which in the formula would be 0.06 or 0.06. And then that's all that gives us, P and R. Find the rate of change of the amount in the account after 3 years. So they're not asking for A. They're not asking for the amount in the account. They're asking for the rate of change of the amount. So let me highlight that just to make it important. Rate of change of the amount. So what they're actually looking for is they're looking for A prime at t equals 3. So let's put everything we know. We know A is equal to 5,000 e to the 0.06t. Well, that's perfect because A is actually a function of t, which means that when you plug in t, you get A. So instead of writing just A, I'm going to write A of t because it's a function of t. Now, what you don't want to do, and it's a very common mistake that I see for this type of problem, is that you don't want to plug in 3 and then find A prime. Because if you plug in 3, it will be a number and the derivative will be 0. So you cannot plug in 3 and then take the derivative. First, you find A prime, and then you plug in 3. So we have that A prime of t is equal to 5,000. And then the derivative of E 0.06t is going to be 0.06e to the 0.06t. And I'll write that y right here because the derivative of e to the cx is ce to the cx. And in this situation, c is a decimal, so it kind of looks weird, but it's okay. So we can multiply 5,000 by 0.06 and simplify that a little bit. So a prime of t will give us 300 e to the 0.06t. And now we can find the rate of change at 3 years. So now you can plug in 3. So that will give us 300 e to the 0.06 times 3. And of course here you're going to have to use your calculator because it's e, and you remember use your e function in your calculator. So that's going to give us, using my handy dandy calculator, the rate of change will be $359, and money, you always round to the nearest hundredth, and 17 cents. So at 3 years, right when it hits 3 years, your account, you're increasing your account by $359, a good amount. And it's increasing because it's a positive, your rate of change. So you're not losing money, you're making money on your investment. Okay, part B. Find the instantaneous rate of change of the amount in the account at the time the balance is 8,000. Okay, so now you want to find A prime, and I should say when A is equal to 8,000. Well, but our derivative is in terms of t, and you don't have t, you have A. So this one's going to be a little different. And there's actually a really nice little trick for this question, and it comes from when we found the derivative before we multiplied the 5,000 and the 0.06 together. So I'm going to rewrite that part. So before I changed it into a 300, it looked like this. Now, I know that before, right, the parentheses was here. So let me put it here. But all of these things are being multiplied together. The 5,000 is being multiplied by the 0.06, and the 0.06 is being multiplied by the e to the 0.06t. So what I want to look at is actually a of t, which I'm going to rewrite here. I know it's above. It's 5,000 e to the 0.06t. So I'm going to use a colored highlight to kind of showcase this. So this right here is the 5,000 and this part at the end. So the a of t is living inside the a prime of t. And that's because of the derivative of e to the cx. Because the derivative of e to the cx has e to the cx in it. So what I can do is I can replace the orange with a to the t instead. So I have a prime of t is equal to 0.06 a of t. So what I did is I just replaced the orange with a. And why should I do that? Well, because I have a. I don't know what t is, but I know that I want the rate of change when a is 8,000. So I can replace a with 8,000. And again, I'm going to use my calculator, and it's actually going to come out to be a perfect number, $480. So when my account has $8,000 in it, I don't know what t is, but I know that it's increasing by 480. What I do know is that t would be greater than 3. How do I know that? Because your rate of change when you're compounding continuously grows more and more as time goes on. Because the more money you have in your account, the more interest you're accumulating. So because my rate of change is higher than my rate of change in part A, I do know that 8,000 will be after t equals 3, but I don't need to know when it is to figure it out. All right, one more. A model for a newspaper circulation is C of t is equal to 83 minus 9 ln of t, where C of t is the circulation in thousands in year t. T equals 0 corresponds to the year 1980. Use this model to estimate the circulation and the rate of change in circulation in 2026. Now, sometimes when people read word problem, they blindly read. So read it once and then go back to see what your function represents. So your function represents a newspaper circulation. The circulation is in thousands, and the year t represents how many years after 1980. So t equals 0 is 1980. C of t is in thousands, the newspaper circulation. So we want this to estimate the circulation and the rate of change in circulation. So you want how much it's circulating and also how much it's changing in 2026. Okay, so 2026 is 46 years after 1980. So the first thing is, if we want to find the circulation, well, that's easy. We just plug in 46. So you don't need rate, right, when you're just looking for the circulation. So we have 83 minus 9 ln of 46. So again, you're going to have to use your calculator, and you use the ln function. And that's going to give us, it's a decimal, so I'm going to write a lot, 48.54227. And the reason that I'm writing a lot is because I actually have to multiply this by 1,000. You always need to be careful of your unit of measure. So because it's newspapers, you are going to round this to the nearest whole number, and the nearest whole number is going to be 48,542. So in 2026, this is how many newspapers are circulating, rounded to the nearest whole. Oh, I forgot an S. Now, what is the rate of change? Well, now I need to do C prime of 46. So first I need to find C prime. And I don't need any algebra here. The derivative of 83 will be 0, and the derivative of ln of t will be 1 over t, so it will be negative 9 over t. So now I can do C prime of 46. So it's going to be negative 9 over 46. And as you can see, this isn't so good for the newspaper because it's negative 0.19. Let's say, actually, let's round it, negative 1.195. So let's do 0.2. So your rate of change, oh, I'm sorry, times 1,000. So let me not round it yet. You can check your calculator. Here we go. So it's going to be negative 196 newspapers. And let me change this one above to the few decimal places. It's very easy to forget that you're in 1000s, right? So normally one of the things that I do to kind of help me with that is always to reread the question one more time before I finish it. Okay, here we go. Okay, so to interpret the results, right? So in 2026, 48,542 newspapers are circulating and decreasing, unfortunately for them, by a rate of 196 newspapers. And that kind of makes sense because, as we know, right, newspapers are not used as much as before. So you have the interpretation of just plugging in 46 into your function and the interpretation of plugging it into the rate of change into your derivative.